This is lesson 13.3, also 13.4. It's just a combined review of multiplying polynomials. And so I'm just going to go through all of these examples and just tell you how to do all of them. You're welcome to pause the video and try it on your own and just see if you've got it right. So for the first few, we're just going to simplify. And we're told that our answer should only have positive exponents. So you just make sure you have no negative exponents in your answer. So just to explain how to do this, I'm going to write it out the long way, expand it. So this is going to be 3p to the fifth. Now, as you noticed from like the first lesson in this unit, when you have exponents like this, you can just add them. And this is the reason why it works, because when you expand it, that's how many p's you've got. So 3p to the fifth. Number 2, everything inside needs to be simplified first. That's really the easiest way to do this. If you were to give everything the second power first, you'd have a bigger mess to clean up. So I like to deal with the first part. So I'm going to put the 2's together and then u to the third over u and then v to the second. And then I can just cancel. That's the only thing to cancel. So I've got 4 u to the third, v to the second, and then that's all to the second power. So then what I'm going to do is all of that will be written twice. So 4 times 4, u to the third, u to the third over v to the second, v to the second. That's going to be 16 u to the sixth, v to the fourth. And that's our answer on that one. Okay, number 3. Because this has an exponent there and this has a separate exponent there and it's not something like that, I'm going to have to give that exponent or that power to everything first. So I'm going to have to deal with that first. So I'm going to have 3 times 3 times 3, v times v times v, u to the third, u to the third, u to the third. So everything gets that third power. And if you're making any mistakes on this kind of a question, you need to be writing it out, because if you're not writing it out, you're really not going to get the right answer if you're making any mistakes at all. You have to really understand how these rules work. On the denominator, I'm going to take everything in here and I'm going to write it twice. So u, v squared, 2 times 2, u, v squared, v squared. So everything gets written. Now, as far as simplifying, I can see that the 2's and the 3's, nothing's going to happen there. So I'm going to have 3 times 3 times 3 on the top, and on the bottom I'll have 2 times 2. Okay, so that takes care of those things. Now on the top I've got v to the third, and on the bottom I've got v to the 1, 2, 3, 4, 5, 6, 7, 8. So how many extra v's do I have on the bottom? If I've got v to the third here and v to the 8th down there, I've got 5 extras on the bottom. So that's how I can take care of that. So all the v's have been taken care of now. For the u's, that's u to the 9th over u to the 1, 2, 3, 4. So where do I have extra u's? I have extras on the top, and how many extras do I have? I have 5. And so that's going to be my final answer for that problem. Okay, for number 4, if the parentheses on this looked like this instead of the way they do, then everything would get the second power. But because the parentheses are where they are, the only thing that gets the second power is what's inside those parentheses. So I always like to start with a new fraction bar, and all of the stuff in the parentheses I'm going to write twice. So I'm going to write 3 times 3, y times y, x to the second, and then 3 times 3, y to the second, y to the second. Now on the bottom, the denominator does not have any power, so it's just 2y. So I look to see what I can cancel. I can cancel this y with this y, but that's it. There's nothing else to cancel. So I'm left with 9 times 9. And I'm left with x to the second times x to the second, so that's x to the fourth. And then I'm left with y times y to the second, y to the second, so that's y to the fifth. And that's going to be over 2. And so that is my answer. Okay, number 5. Now we do have some negatives in here, so let's talk about the different kind of negatives we have. We have a negative in front. That's not an exponent, so that is the sign of what we're dealing with. So that's going to be dealt with differently than the exponents that are negative. Okay, so we're going to keep this negative sign. We have to keep that, but the negative exponents are going to turn positive as soon as I move things around. Okay, so they're dealt with differently. So as I like to do, I like to start with a new fraction bar, and the first thing I'm going to do is I'm going to put that negative sign right there. I'm going to make it a -1 just so I remember that it's there. And then I'm going to write yx to the third, and I'm going to go ahead and expand it out. Now on the bottom, I am going to, because the parentheses are just around here and then I have this power, I'm going to need to get this power kind of distributed out. So everything down here gets a -1 power. So I have x to the -1, y to the -1, 2 to the -1, y to the -1, and then x to the -3rd to the -1. So we'll talk about that part in a second. Because all of these have negatives, they're all going to move. So I'm going to have the -1, y, x, x, x on the top. And then this one's going to go up there, this one's going to go up there, this one's going to go up there, and this one. And so once I move it, I don't have that negative anymore. Now keep in mind, I still have this because that's a different kind of negative. That's not an exponent. Now for this one right here, x to the -3 to the -1. Okay, so the -1 would put it up top, but then x to the -3 would come back on bottom. So it's going to be x to the 3rd power on the bottom. And actually I'm going to write that in expanded form. And then I can go through and cancel. And I'm going to simplify. So I'm going to have a -1, and I'm going to have x, times 2. So it's going to be actually -2. And then I'm going to have x, and then I'll have y to the 3rd, and over 1. So this is my answer. So there's no negative exponents in my answer, but there is a negative sign, and that's different. You can have a negative sign. Okay, for number 6, this down here at the bottom, again, looking at the way the parentheses are, all of this, everything on the bottom, because of that negative exponent, everything's moving to the top. And because of this, that's moving to the bottom. So what I'm going to do is I'm going to flip everything around. So I'm going to start with a new fraction bar. The b to the +1 is going to be down there. And then I'm going to have -2. Nothing else is changing. But it's to the positive 2nd power because I moved it. All right, now there's going to be some other things that are going to have to move, but I'm only dealing with one thing at a time. Okay, now everything in the parentheses is now going to be raised to the 2nd power. And so I'm going to have -2 times -2, a to the -1 times a to the -1, b to the 3rd times b to the 3rd, -3 times -3, b times b. Now a to the 0 is just 1, so 1 times 1 is 1, and I'm not even going to write that. And then I've got b to the 1 on the bottom. So the next thing I need to deal with is I need to deal with this. Because of those negative exponents, they're going to come down to the bottom. So I'm going to have a times a, so a to the 2nd power on the bottom. So I'm going to just cross those off there. So now I need to simplify what is left. And so looking at what I have -2 times -2, which is 4, -3 times -3, which is 9, so I have 36. And then I have b to the 3rd times b to the 3rd, that's b to the 6th, 7th, 8th. Over, and then in alphabetical order, a squared b. I'm not done because I have b's on both top and bottom, so I need to simplify that. So how many extra b's do I have, and where are they? So I have more b's on the top than I have on the bottom, and how many extras do I have? I have 7. And so this is my final answer. So as you're dealing with negative exponents, it's very important that you're just doing one small step at a time. If you try to take on too much, you are going to get lost and confused with all of the negatives. So please be really careful about that. Okay, number 7. Everything in here is going to get that 3rd power. So I'm going to have 2 times 2 times 2, and then n to the 3rd, n to the 3rd, n to the 3rd. On the bottom, -2 m n times. Now, this is really important because it's a super tricky one. On this one, that's -1 times n to the 2nd. So the -1 does not have the 2nd power. So it's not going to be -1 times -1. It's just going to be negative. So the negative is not going to turn positive there. And then n to the 2nd power. So that's really important to understand. I actually think I'm going to expand this n to the 2nd power out like that. So now if I take these n's right there, that's n to the 3rd, and that will cancel with one of those. And then I've got a 2. And now I've got a negative times a negative. That's going to be positive. So my new fraction is going to be a positive. Okay, on the top I'm going to have 2 times 2, n to the third times n to the third. And on the bottom, all I've got left is m. So if you look at how would you have dealt with that problem, probably one of the most common mistakes, well, a couple of the most common mistakes that I see on something like this is people saying 2 to the third power is 6, and that's not correct. Another really common mistake that I see is people doing negative squared is positive, and that's not correct because that negative does not have that power. And so if you look at it, if it was written like this, then that would turn positive. Okay, but because of the fact that there's no parentheses, then n is the only thing that has that negative or the second power, and so the negative is still there, and then n to the second power like that. Okay, the next part, find each product. So what I'm going to do is multiply and by distributing, so the distributive property. So I'm going to take 2m times m, so 2m squared, 2m times negative 5, negative 5 times m, and negative 5 times negative 5. Then I combine my like terms, so these are my like terms right there. So I'm going to have 2m squared minus 15m plus 25, and I'm done. Okay, there's nothing else you can do. You cannot combine m squared and m by adding or subtracting. So you're finished. That's a trinomial product. Okay, number 9. 4n times 6n is 24n to the second power. 4n times 6 is 24n. So you can multiply non-like terms, but you can't add or subtract them. 8 times 6n is 48n, and 8 times 6 is 48. So combining my like terms, I'm going to have 24n squared plus 24 and 48 is 72n, and then plus 48, and that is my answer. Okay, number 10, again distribute everything. So I'm going to have 6b times 8b is 48b squared. 6b times negative 5, watch your signs. Negative 4 times 8, and negative 4 times negative 5. Combining my like terms. Now, when you have this type of product or this type of multiplication problem, usually your like terms will end up in the middle because that's the most common type of thing that we practice with at this stage. So you will see a lot of that. So look for like terms there. And then when you have that answer, you're done. Now, number 11 is a little bit harder because it's a binomial times a trinomial. And so you need to be super careful with making sure you take care of every bit of it. So I'm going to start with 4b times 4b squared. So it's going to be 16b to the third. And then 4b times negative 2b is negative 8b squared. And then 4b times negative 6 is negative 24b. Then I'm going to take the 3 and multiply it by everything. So plus 12b squared minus 6b and minus 18. So you just have to make sure everything gets distributed. It's called the distributive property because every part of that has to be distributed out. Now look for like terms. 16b to the third, there's nothing that's going to go with that. There's no other b to the third. So I'm going to write 16b to the third, and I'm going to cross it out to make sure I've got it. The b squares, I've got negative 8 plus 12, so that's going to be plus 4b squared. And then negative 24b minus 6b, and then minus 18. And so that's my answer. Okay, now starting with number 12, we're going backwards. We're doing the multiplication backwards, so we're factoring out. It's like when we have 12 and we say that's equal to 2 times 2 times 3, we're finding the factor. So we're saying what times what gives me this polynomial. And so the first way that we look at this is with the GCF, so the greatest common factor. So what I do, just to remind you, and I'll do this with a couple of the problems, you're going to take each term. So we have 3 terms, and we have to find what is common. And so let me just write this out. You don't necessarily have to do this for every one because a lot of you can see like what you're looking at. But sometimes it's kind of hard, especially if you have multiple terms, to see what the greatest common factor is. So let me just write this out. I'm breaking everything down into factors. And I won't actually worry about the negative part. We'll take care of that in a minute. So 72. And so that's 8 times 9. And then x to the second y. So looking for what do they have in common? What do all three of those have? Well, they all do not have a 2. They all have 3's. Okay, so 3 times 3 is 9. They all have 2 x's. So x squared. And they all have a y. So 9x squared y, that's my GCF. Okay, so now what I do is I look at what's left. So what's left over is 2y. I wish I had more room. I'm going to write 2y. And then I have 3x. And I have 2 times 2 times 2, which is 8. Okay, so now I'm going to erase what I have just so I can write this in the right place. So what you do is you take your GCF. And you say, I'm going to multiply that by what? So what do I multiply that by to get 18x squared y squared? 2y. And then I've got plus 9 times what is 27? So 3, and then x squared times x, and then the y. That will give me the 27x to the third y. And then this minus sign has to go there. So 9 times 8, and then I'll have the x squared y. And so this is your answer. So now, instead of multiplying it together, we're pulling it apart. So these are our factors. So here is one factor, and there is the other factor. That's what you multiply together to get this polynomial. Okay, so looking at these for the GCF, if you're having trouble finding the GCF, then you need to write it out like I did on this number 12. You need to write it all out, all the factors, and circle everything that they have in common. I'll do that with one more problem, and then after that I'll just write out what the GCF is. So on number 13, I'm going to write 10 and then y to the fourth x. So to write that out is 2 times 5 times y times y times y times y times x. 5y squared x to the third is 5. I didn't make these problems up, and I do not like that they're not in standard form. I don't like that the y's are coming before the x's. That's actually not something that we would do, and so I'm not really sure why this program has it like that, but whatever. Okay, looking for what they have in common. They all do not have 2's, because the purple, no 2's, but they all do have a 5. So that's going to be part of my GCF. They all have 2 y's. So y squared. They all do not have x's. So that's my GCF. Now as far as what's left over, I've got 2y squared x. So 2, I just can't write it like that. So I'm going to write it like this. And then I've got x to the third. And then I've got 4. Okay. So now I'm going to take my GCF. And I'm going to write 5y squared times 2xy squared plus x to the third plus 4. That is my answer. So you're just using these numbers that were left over there along with the GCF to write what you would have. Okay, for number 14, like I said, I'm just going to write what the GCF is. Now, if this leading one is a negative, it is actually more correct to pull the negative out with it. 5, 25, and 20, they all have 5 as a common factor. So I'm going to take the negative 5 out, not just a 5. Is it wrong if you just take a 5? Well, that's debatable. I think it is. I like to take the negative out. I notice that these all have y's, and they actually all have 5 of them. So I'm going to take y to the 5th out as a GCF, but that's it. There's nothing else that they have in common. So what do I multiply negative 5y to the 5th to get this? I'm going to have to multiply it by y to the 2nd and then x to the 3rd. Oh, that bugs me. And then I'm going to have plus, and I'm going to have, now this one you got to be careful because it's a negative times whatever is there has to be a positive. So I'm actually going to make that a minus sign right there because a negative times a negative will give me a positive 25, and then y to the 2nd will give me the y to the 7th. And then I'm not going to put a minus right here because if I did that, then I'd have a negative times a negative, and that's not going to give me what I want. So I am going to write a plus because a positive times a negative is going to be negative, and that's what I do want there. And then 5 times 4 is 20, y to the 5th, so this is my answer. Okay, number 15. Again, with that leading coefficient being a negative, I'm going to pull out the negative with it. And if I look at 42, 36, and 54, they all have 6 in common. Okay, 6 times 7, 6 times 6, 6 times 9. So I'm going to have a 6 be part of my GCF. B to the third, B to the second, B to the third. So B to the second is what they have in common. And they all don't have A's, so that's my GCF right there. So negative 6 times positive 7 is 42. B to the second times B is B to the third. Watch your signs. You've got a negative times something is a positive, so it's going to have to be a minus right there. 6 times 6, B to the second. I don't have to put any B's there, and then A. On problems like this, it probably would not be a bad idea to write out all the factors like I did on the first 2 questions. Especially where you haven't been doing this for very long. Probably make this type of problem a lot easier. So I'd probably recommend, like on a test quiz, that's probably what you should do. I'm going to go ahead and do that for this next problem. First of all, because I have the room to do it, and second of all, I do think it's a good idea. So 40 is 8 times 5, and then x squared, and 35 x to the third y is 5 times 7, and then negative 15x squared y. I'm going to go ahead and write the negative 1, and I'll show you like how that helps me in just a second. You don't have to do it that way, but you do have to be careful with your signs. Looking for what they have in common. They all do not have 2's. They all do have a 5. They all have 2 x's. They do not all have y's. So my GCF is going to be 5x to the second. And then looking at what is left over, 2 times 2 times 2 is 8. So I'm going to have 8. And then plus, and I don't see anything to contradict that, so 7xy. And then on the last one, I've got negative 1 times 3, so it should be negative 3. And check the sign on that. That'll give me negative 15, so that looks right. And then y. And that's my answer. So on these problems, the answers are what used to be the question. So we're just working backwards on all of these. Okay, the last few questions are story problems, and you'll have questions like this on your homework. So number 17, a plot of land is 30 meters longer than it is wide. So we do not know how long it is or how wide it is. So I'm going to call this W, but it's 30 meters longer than how it is wide. So that's what the length is. So what is the length? The length is W plus 30. What is the width? W, and you can use whatever letter you want. What is the formula for the area of the triangle? Well, the area is length times width. So that would be the answer to C. And what is the area of this triangle? So multiply it out. It's going to be W squared plus 30W, and that's going to be in units squared because that's how we write area. And that's the area. You can't do anything any more than that. That's all you can do because we don't have any more information. For number 18, though, it says for the same land above, if a sidewalk is to be installed around the land and it's to be 4 meters wide. So think about how that's going to look. It's going to look like this. We're going to have this sidewalk installed, and that's going to add 4 and 4 and 4 and 4. And so what is the new area of this pool or walkway? Whatever it is. So if you look at how long it is, instead of being W plus 30 that the blue is, I'm going to add another 8 to that. So it's going to be W plus 38. And on the width, instead of being W, it's going to be W plus 8. So that's what my new area is going to be. So I'm going to have W squared plus 8W plus 38W plus 304, and so simplifying that, W squared plus 46W plus 304 units squared. Whoops, units squared. And that is the area of this land, pool, walkway, whatever it is that we're talking about. Okay, and then the last one, it says a mural is to be put on a wall. It must be centered on the wall with each side of the mural 2 feet from the edge of the wall. So let's draw the wall. Okay, so here's the wall, and I'm going to put a mural on the wall, and it has to be the same distance away from all the edges, and it's going to be 2 feet, 2 feet, 2 feet, 2 feet. So this is really the same type of question. It says the length of the wall, so the wall is the green part, and the length of the wall is 10 feet more than the height. So here's the height, okay, and this is the wall, which is h plus 10. Now it says, what is the polynomial that describes the area of the mural? Okay, so how big is the red part? So if the green part is h plus 10, I'm going to take away 2 feet and take away 2 feet. So I take away 4 feet. Maybe I should write that in red. And then here I'm going to take away 2 feet and take away 2 feet. So I'm going to take away 4 feet. So the area of the mural is going to be h plus 6, because that's what 10 minus 4 is, times h minus 4. And when I multiply that together, I'll have h squared minus 4h plus 6h minus 24. So that simplifies to h squared plus 2h minus 24 units. Oh, it's actually feet. I know that one. Feet squared. And actually, going back to this previous problem, it's actually meters. So we can actually change that because we know that it's meters. Okay. Oops. All right. So with that, you can do your homework. All the problems are just like what we just saw.